Section 9.1 is an introduction to set theory. I would pause the video and write down these definitions. So a set is a group of elements that have all been classified in the same way. So for example, the set of all even numbers, or a set of students in IB Math Studies, or some kind of grouping that share some kind of classification. An element is one item or number in the set. So if you're talking about even numbers, then 2 would be an element. 4 would be an element. If you're talking about IB Math Studies students, one student's name would be an element. This notation here, n parentheses, in this case we're calling it set A, is the number of elements in set A. So if you're talking about the number of students in a certain period, then n of A might be 30. An empty set is a set that has no elements in it, denoted by either brackets with nothing in between or a 0 with a cross through it, and that means the empty set. Set notation is these curly brackets, and an ellipsis shows that the pattern continues. This notation here means included in, so this is saying X is included in the set of A, and then, or an element of, and if you put a cross through it, it means that X is not an element or not included in the set of whatever A is. So some examples of sets: positive even numbers, 2, 4, 6. So this is the set notation. It goes ... because that means it goes on forever in that same pattern. We have our notation here from back in chapter 2. Remember, the boldface R is all your real numbers, so anything that's not imaginary. The boldface Q is your rational numbers, so anything that can be written as a fraction. So whole numbers, fractions, decimals that end, decimals that repeat. Integers are not fractions. They can be positive, negative, or 0. Natural numbers are 0 and the positive integers. And irrational numbers, which is the boldface Q with the tick mark next to it, those are things that cannot be written as fractions. So decimals that never end and never repeat. Numbers like pi or the square root of 2. This first example defines set A to be the set of all perfect squares or square numbers less than 100. So part A wants us to write down the elements of A, which just means list everything that exists in that group. So all the odd perfect squares less than 100 would be 1, 9, 25, 49, 81. So those are just all the numbers that exist in this group. So then n of A says how many actually exist in the set. What's the number of elements in the set? So if you just count them out, you have 1, 2, 3, 4, 5. So n of A, there are 5 elements in the set of odd numbers less than 100. So writing out the elements, you just actually list every single element in the group, and then n of, that's notation for saying the number in the group. There's 5 in this group. This next example defines A to be the set of X such that X is included in the set of integers, and 1 is less than or equal to X is less than 10. So all numbers between 1 included and 10 not included, and integers. So part A wants you to list all the elements in the set, and part B wants you to find n of A, or the number of elements that exist in set A. So go ahead and pause the video and list all the elements in the set and find out how many exist in the set. So the elements in the set are all the integers between 1 included and 10 not included. So that's just 1, 2, 3, 4, 5, 6, 7, 8, 9. So just listing all of those out. And then the number of elements in the set, you just count up how many elements are in their set. Well, 1 through 9, there are 9 elements in the set, so n of A is 9. This next example defines set A to be the set of all positive integers less than 15. So we want to first write this in set notation, so that's the curly bracket notation that we saw in the previous example. So go ahead and pause the video and see if you can duplicate what we saw in the previous example and write this description in set notation. There's a few different ways you can write this. The most straightforward way is to duplicate what we saw in the previous example. So X such that, which is either a bar or you'll see 2 dots like we saw in the previous example. So this is defining what your variable is. X is included in the set of integers because we want integers here. And then if they're positive, well, the first positive integer is 1. So I want to start at 1, I want to include 1, and I want to be less than 15, which implies not less than or equal to, so less than 15. There's a couple other ways to write it, but this is the most straightforward way. So X such that X is included in the set of integers, that's this part here. 1 less than or equal to, so that makes sure they're positive, X, which is less than 15. So go ahead and pause the video and list all the elements in the set and find n of a, the number of elements in set A. So if you list out all the elements in the set, that's just listing numbers 1 through 14 because you don't want to include 15. If you want to be lazy about it, this is where your ellipses would come in. So I listed out 1, 2, 3, and then I have ... here. That means the pattern continues until you get to 13 and 14. So that just tells you in here, it implies all of this 4 through 12 without having to write it in. And then number of elements in set A, we'll just count them all up, 1 through 14, there's 14 elements. There's 14 things that exist in that group. Section 9.2 is subsets and complements of sets. I would pause the video and write down these definitions. So the universal set, which we denote with the letter U, is the set for which all other sets are subsets. So it's something that's not usually given, but sometimes you can find out in context. So sometimes that might just be all the numbers in the whole universe. It might be, if you're talking about students, the universal set might be students at Newport Harbor High School, the big overarching group. It might be all high school students. It might be all students at a certain college. Whatever it is, whatever the big overarching group is, that's your universal set, which we denote with the letter U. A subset is a subgroup of whatever set you're talking about. So if we want set A to be students at Newport Harbor High School, then set B would be a subgroup of that. So students in a certain class, female students, male students, students who play sports, that kind of thing. Those are all subgroups of your bigger set. The empty set is a subset of all other sets. That's always a subset. The original set, so again, if you go back to the set of Newport Harbor students, so the set of Newport Harbor students is by definition a subset of itself. It's a subgroup of itself. This notation here denotes a subset. So B is a subset of A. Okay. The notation here without the equal to, think of this as like a less than or equal to, and this is just a strictly less than. That means that B is a proper subset of A, which means it has fewer elements than the original set. So it has a fewer number of things in it than the original set A did. Okay, this one, they could be equal to each other. They can have the same number of elements. This one here, it can have only less than the number of elements. So again, think of this as a less than or equal to and just a strictly less than. A complement of a set are all the sets that exist in your big overarching universal set, all elements that exist in your big overarching universal set, but do not exist in the given set. So for example, we denote a subset with a little apostrophe here, or also with a little C up in your superscript. An example of a complement of a set, let's say your universal set, your big overarching group, are students at Newport Harbor High School, and you're talking about the set of female students. The complement would be all students who do not identify as female. That's all the students that exist in the big overarching group, but not in the group that you're talking about. So here we have an example. We're defining the universal set to be all high school students in the whole wide world. Set A, so the group that we're talking about, are specifically students at Newport Harbor High School. So this is your big overarching group. This is the group that we're looking at. We want to find 4 different subsets or subgroups of this set. So go ahead and pause the video and find at least 4 different subgroups of students at Newport Harbor High School. And then check with your neighbors and see if you guys got similar subgroups or if anyone has a different subset as you. So some example of subsets of students at Newport Harbor High School would be athletes at Newport Harbor High School, or even more so, students on specific teams, students on the basketball team, students on the football team. That's a subset. Students in a specific class or in the whole diploma program, that would be a subset. Female students or male students, that would be a subset. Seniors, that would be a subset. Juniors, sophomores. So here are 4 examples of subgroups of our group Newport Harbor students. So now I want you guys to name at least 2 elements, so actual, in this case, people, because we're talking about people, that are in the complement of set A apostrophe, which is the complement of set A. So who exist in the universal set, all high school students, but do not exist in the set of Newport Harbor High School students. So name two elements in this complement. So this would be students who are high school students, but do not go to Newport Harbor High School. So name two people who are high school students that you know, but don't go to Newport Harbor High School. So my cousin Abby, my cousin Maddie. They are not students at Newport Harbor High School, but they are high school students. So they are in the universal set, but not in set A, the set of Newport Harbor High School students. Given that the universal set is the set 1, 2, 3, so on and so forth up through 12, and set A is 3, 6, 9, and 12, find A complement. So remember, A complement is anything that's in the universal set that's not in set A. So go ahead and pause the video and find A complement. So since A is all the multiples of 3 between 1 and 12, then A complement would be everything that's not a multiple of 3 between 1 and 12. So 1, 2, not 3 because it's an A, 4, 5, not 6 because it's an A, 7, 8, not 9, 10, 11, and not 12. So this would be A complement. Everything that is in the universal set, U, but not in set A. The last part, using all the notation that we had on the very first slide and on the second slide that had the definitions with 9.2, write all of these in set notation. So X is a member of a set, not a member, a subset, the elements are this, there's a number of elements, and also that they contain these vowels. So go ahead and pause the video and write all of these in set notation. So this is all the notation that we've had for these two sections. So this is saying that X is included in the set of A, or is a member of. This is saying X is not included in the set of A, so with the cross through it. This notation that looks kind of like a less than or equal to, that's our subset notation. So B is a subset of C. The elements of the set A are X, Y, and Z, so A is equal to, in set notation with the curly brackets, X, Y, Z. The number of elements in set A are 3, so remember this N of A is our number of elements notation, so that is equal to 3. And set B contains the vowels A, E, I, O, U, so B is equal to, in set notation, A, E, I, O, U. So this has been an introduction to set theory and subsets and complements.